In this class, we're going to consider how you factorise a quadratic expression using a common factor. So remember, a quadratic expression in general is in the form ax squared plus bx plus c. But the only requirement on this is that the x squared term remains. So in other words, the b and the c values can go to 0, leaving you just with an x squared term, and that's still a quadratic expression because it still preserves the x squared term, which is the thing that makes it a quadratic. In this class, we're looking at a particular form of quadratic where basically we've lost the number term. So the c term, the c value, the constant value has gone to 0. And then maybe these terms are, for example, flipped around or they have a negative. But essentially, you're keeping the x squared and the x term and losing the c term. And these factorize in a particular way. So there's three options with these guys. They either factorize into two brackets as a trinomial. They factorize into one bracket using a common factor, and that's what we're going to look at today. Or they factorize into two brackets as a difference of squares. So three different ways that these quadratic expressions can factorize, depending on the original structure. So we're looking at this kind of middle option, I guess you could call it today. So starting with the first one, it's fairly straightforward, this technique. We're just trying to identify the common factor. So looking at this expression here, this is the first term, then this is the second term. The common factor is an x, so we're just going to pull that common factor out in front of a bracket, just like that, and then we just need to figure out what goes inside the bracket. So x times something to make x squared, so that will need to be another x. X times something to make minus 7x, so that will need to be a minus 7, and that's basically how that works, and that's it fully factorized. Okay, so looking at the next one, so x squared plus 10x, so common factor of x again. X will be your common factor for a lot of these. Certainly the early questions that you do, you'll just have a common factor of x, and then they might get a little more complicated as in these two over here. So we would need x times x to make x squared, x times 10 to make 10x. So just a one-step process, one line of working. So moving on to this guy here, a little bit more, well, very slightly more complicated. Remember, you're always trying to pull out the highest common factor. There's common factors and there's highest common factor. If you pull out a common factor but not the highest common factor, then you would need to factorize the inside of the bracket again, and that just starts to get a little messy. So try to make sure you get the highest common factor. So certainly x is a common factor here, but so is 2, because 2 divides into both 2 and 12. So to get the highest common factor, we're going to use 2x. Okay, and then we just stick down the bracket and we need to figure out what goes in the bracket. So 2x times something to give you 2x squared, that will be an x. 2x times x gives you 2x squared. And 2x times negative 6 to give you minus 12x. So slightly more complicated, that one, but not terribly so. Okay, so one other slight change in the format you might see is when the terms are reversed. Now they've only been reversed because the x squared has got a negative. If the x squared has got a negative, then we don't like to have the negative sort of hanging out the left-hand side like this. So instead of writing it like this, generally in that scenario, we're just going to turn it around so that the negative is in the middle. That's just a kind of mathematical convention. So it's the same thing though, we're still trying to identify the common factor, which is x. You've just got to be careful with these that you preserve the order of the original expression. So it's very tempting to put the x in here, but x times x would give you positive x squared, and we want a negative x squared. So that means that we need a minus x in the second position, and we just need to put a 6 in the first position. So x times 6 gives you 6x, x times negative x gives you negative x squared. Let's maybe do one more. Let's do another one kind of like this. So let's go for, let's say 5x minus 15x squared. So a similar format. This time we're looking for a common factor which is slightly higher than just x because you've got a 5 common factor between the numbers. So the total common factor is 5x. In other words, you can use 5x to divide into both that term and that term. So pulling out 5x is our common factor, just trying to figure out what goes in the bracket. So 5x times 1 gives you 5x, and 5x times minus 3x gives you minus 15x squared. That's basically how that works. So 5x times x gives you positive 5x. 5x times minus 3x gives you minus 15x squared. So that's basically how you factorise quadratic expressions using a common factor. There can't be a number term when it's a common factor because the common factor needs to be common to all the terms. If these guys have both got x's in them, then there can't be a number on the end, or there wouldn't be anything common. Unless, for example, you had 2, 12, and then like a 4, which has all got a common factor of 2, but we're talking really about a common factor that includes an x term as well. So that's basically how you go about that technique. It's fairly straightforward. If you've already factorised expressions in general, algebraic expressions using a common factor, these are in particular quadratic expressions, but any expression using a common factor is pretty much the same process. So if you've already done that in other algebra topics, then this is not going to be much of a stretch beyond that. So check out a few practice questions on this technique just to reinforce what I've talked about there today.